Send my wife our flight details and put it on my calendar. One sentence. Behind it, 3 real actions. But a language model on its own can do exactly one thing: produce text. It can't open your calendar. It can't send a message. It can only describe what it would do. So how does one sentence become a chain of real actions without the assistant losing track of what it's doing halfway through? That single reply you see can hide 5 separate model calls behind it. Here's the trick the whole system turns on. The model still only produces text, but now we let one of those texts be a request, a structured note that says, run this tool with these inputs. The model asks, something else acts. Think of a chef's expeditor at the kitchen pass. They never cook. They read the order, call out to each station, and wait for the plate to come back before sending the next instruction. The agent loop is exactly that, a simple loop wrapped around a model that by itself can't do anything. Reason, act, observe, repeat. Before the model can ask for anything, it has to be handed what it knows. Every single turn, the runtime builds the prompt from scratch. It stacks 4 things: the assistant's personality file, the list of tools it's allowed to call, your long-term memory, and the current time. Then it adds the whole conversation so far. Here's what engineers learn the hard way. That conversation only grows. Every tool result gets appended and resent on the next turn, so the prompt balloons. That's why OpenClaw runs compaction, quietly trimming old context before it overflows the window. The model is stateless. The loop is what remembers. So the model emits its request, and here's the part that surprises people. That request is just text, a small block of JSON, an ID, the tool's name, and its inputs. The model didn't open anything, it wrote a note. Now the runtime takes over. The skill loader finds the matching tool, runs it for real, the actual calendar, the actual message send, and captures what comes back. That result gets wrapped as a new message and fed straight into the conversation, as if a user had spoken it. Treat that JSON like untrusted input, because it is. The model is guessing, and a wrong tool call runs real code on your machine. Now watch a whole message go around. Phase 1 intake, your message arrives and gets saved. Phase 2, assemble the context. Phase 3, the model thinks and asks for a tool. Phase 4, the runtime runs it and feeds the result back. And then this is the loop, it goes around again. New context, including that result. The model thinks again. Maybe it asks for a second tool, maybe it's done. Each pass is 1 round and OpenClaw counts them. The moment the model returns plain text instead of a tool request, the loop breaks, and the reply streams back to you, word by word, so you watch it work instead of staring at a spinner. That's the happy path. Now break it. What if the model never returns plain text, it just keeps asking for tools round after round? Without a stop, the loop runs forever, burning money on every call. So OpenClaw sets a hard ceiling, 5 rounds, hit it and the loop ends no matter what. That's the fuse. Second failure, a single tool hangs, a slow website, a dead connection. So each model call gets a timeout of 120 seconds. Third, 2 of your messages arrive at once and their tool calls collide. OpenClaw refuses to run them in parallel. 1 session, 1 command at a time in order. Slower, yes, but the alternative is 2 half-finished tasks corrupting each other. Here's the whole loop in one picture. A message enters through the gateway. The runner assembles context, personality, memory, tools, history. It calls the model. The model either asks for a tool, which the skill loader runs and feeds back, or it answers, which streams to you and gets logged. Wrapped around all of it, the round counter, the timeout, the compaction. So every time you design an agent, ask 3 questions. What does the model see each turn? How does an action actually happen? And when does it stop? Answer those 3 and you've built an agent loop, a while loop around a model that on its own can only talk.